we'll list a whole bunch of innovations, and then when you add them up, you get a total improvement in energy density and cost.
Elon Musk has just dropped a bombshell. Tesla's all-new aluminum-ion battery is here, and it's a game changer that promises to eliminate the competition in one decisive move. Faster, more efficient, and more durable than anything we've seen before, this battery could be the single greatest innovation in EV history. Imagine charging your electric car in just 15 minutes and having a range that outlasts anything on the market today. This isn't some distant dream, it's happening now. But what makes this battery so groundbreaking? Why is everyone from automakers to energy companies scrambling to respond? And most importantly, how will this innovation impact you and the future of our planet? What's happening? Tesla's journey to becoming the leader in electric vehicle technology has always been powered by its relentless focus on battery innovation. From the very beginning, Elon Musk understood that the success of electric vehicles hinged on creating batteries that were not only powerful but also affordable, efficient, and practical for everyday use. This focus has driven Tesla's mission to make electric vehicles the new standard in transportation. When Tesla launched its first car, the Roadster, in 2008, the automotive industry wasn't ready for what came next. The car's battery pack was built using thousands of small consumer-grade lithium-ion cells, the kind typically found in laptops. It was an unconventional choice that shocked the industry, but delivered a game-changing result. The Roadster offered a range of over 200 miles on a single charge, far surpassing any other electric vehicle at the time. These cells, known as 18650 cylindrical cells for their dimensions of 18 millimeters in diameter and 65 millimeters in height, became the foundation of Tesla's early success. However, while they delivered impressive range, they had limitations. These batteries required extensive cooling systems due to their high internal resistance, and scaling them for mass production proved costly and challenging. Tesla's engineers quickly realized that if they wanted to revolutionize transportation, they needed to keep innovating. In 2017, Tesla unveiled a new battery format, the 2170 cell. Measuring 21 millimeters in diameter and 70 millimeters in height, these larger cells offered better energy density and were more cost-effective to produce. Used in the Model 3 and Model Y, these batteries marked another leap forward, improving performance and bringing down the cost of electric vehicles. But Elon Musk was never one to stop at better. He was always chasing the best. In 2020, Tesla introduced its most ambitious battery design yet at its Battery Day event, the 4680 cell. These batteries, named for their 46mm diameter and 80mm height, promise to increase energy density by 5 times and power output by 6 times compared to the 2170 cells. Even more impressive was Tesla's tabless design, which eliminated the internal tab inside the battery cell, allowing for faster manufacturing, improved heat management, and greater reliability. The 4680 battery represented a massive leap in battery technology, but for Tesla, it was still just a stepping stone. Elon Musk and his team knew they were on the brink of something even bigger, a breakthrough that could finally eliminate the limitations of lithium-ion batteries and deliver the performance electric vehicles had always promised. The birth of aluminum-ion batteries. Enter the aluminum-ion battery, Tesla's latest innovation and perhaps its most revolutionary yet. This new battery technology solves many of the problems that have plagued lithium-ion batteries for years. Faster charging, longer lifespan, and greater safety are just the beginning. The aluminum-ion battery represents a shift in material science that changes the rules of energy storage. One of the key innovations of the aluminum-ion battery is its use of solid-state electrolytes instead of the liquid electrolytes found in traditional lithium-ion batteries. Liquid electrolytes are prone to flammability and can cause thermal runaway, a dangerous chain reaction that can lead to fires or explosions. Solid-state electrolytes, on the other hand, are far more stable, making aluminum-ion batteries inherently safer. Another breakthrough lies in the battery's anode design. Traditional lithium-ion batteries use graphite anodes, which have a limited capacity for storing lithium ions. Tesla's aluminum-ion batteries replace graphite with silicon nanowires, a material that can theoretically store 10 times more lithium. This results in higher energy density, meaning the battery can store more power in a smaller size. However, silicon has its own challenges. It expands and contracts during charging cycles, which can degrade the battery over time. time. Tesla's engineers have developed advanced stabilization techniques to address this issue, ensuring that the aluminum-ion battery remains durable and reliable over thousands of charge cycles. The result? A battery that charges in as little as 15 minutes and offers significantly longer range than anything currently on the market. This innovation not only solves the range anxiety that has kept many consumers from switching to electric vehicles, but also addresses the issue of long charging times, making electric vehicles more convenient than ever. Impacts on Tesla's current lineups. Tesla's aluminum-ion battery isn't just a scientific breakthrough, it's a transformative development that will impact every vehicle in its lineup. From the compact Model 3 to the powerful Tesla Semi, this new battery technology will redefine what these vehicles are capable of. One of the most exciting possibilities is the potential for ultra-long-range vehicles. With higher energy density and improved efficiency, Tesla's aluminum-ion batteries could enable electric vehicles to travel over 500 miles on a single charge. For the Tesla Cybertruck and Tesla Semi, this means delivering the power and range needed for heavy-duty applications without compromising performance. But the benefits don't stop at range. The reduced charging times of aluminum-ion batteries make owning an electric vehicle even more convenient. Imagine being able to fully charge your car in the time it takes to grab a coffee. This could eliminate one of the last major hurdles for widespread electric vehicle adoption. Additionally, the new battery technology could bring significant cost savings. By using more abundant and less expensive materials, Tesla can reduce the overall cost of its battery packs. This in turn could make electric vehicles more affordable for the average consumer, accelerating the transition away from internal combustion engines. Why this matters beyond Tesla. While Tesla is leading the charge, the implications of the aluminum-ion battery go far beyond the company's vehicles. This technology has the potential to reshape entire industries, from renewable energy storage to consumer electronics. One of the most significant applications is in grid storage. Renewable energy sources like solar and wind produce power intermittently, creating a need for reliable storage solutions. Tesla's aluminum-ion batteries could store more energy in less space, making them ideal for home energy systems like the Tesla Powerwall or large-scale solutions like the Tesla Megapack. In consumer electronics, the increased energy density of aluminum-ion batteries could lead to smaller, lighter, and longer-lasting devices. Imagine smartphones that only need to be charged once a week, or laptops that can run for days without being plugged in. Even the aviation industry could benefit from this innovation. Battery weight has long been a barrier to electric flight, but the lighter, more efficient aluminum-ion batteries could make electric planes a reality. Finally, this technology has the potential to reduce our reliance on rare and environmentally harmful materials. By using less cobalt and moving toward more sustainable production methods, Tesla is setting a new standard for what battery manufacturing can look like in a more eco-conscious world. Tesla's aluminum-ion battery isn't just an improvement, it's a revolution. By solving the fundamental challenges of energy storage, Tesla is not only advancing the electric vehicle industry, but also opening the door to a future powered by clean, sustainable energy. This is more than a step forward for Tesla, it's a leap for humanity. Aluminum-ion versus lithium-ion. Why this new technology matters. For decades, lithium-ion batteries have been the backbone of modern energy storage. From powering smartphones to making electric vehicles possible, they've transformed countless industries. However, as revolutionary as lithium-ion technology has been, it has significant limitations. Tesla's aluminum-ion battery represents a paradigm shift, addressing many of the challenges that have held back lithium-ion batteries for years. One of the key advantages of aluminum-ion batteries is their rapid charging capability. Traditional lithium-ion batteries rely on liquid electrolytes, which slow down the movement of ions between the anode and cathode. This creates a bottleneck that limits charging speed and generates heat. Aluminum-ion batteries, on the other hand, use solid-state electrolytes. These electrolytes enable ions to move much more efficiently, allowing the battery to charge in as little as 15 minutes without overheating. Another critical improvement is energy density. Lithium-ion batteries have reached a plateau in terms of how much energy they can store in a given volume. Aluminum-ion technology, with its silicon nanowire anodes and advanced cell architecture, can store significantly more energy. This means aluminum-ion batteries can deliver the same or greater power in a smaller, lighter package, making them ideal for applications where weight and size are critical. Safety is also a major major concern with lithium-ion batteries. The flammable liquid electrolytes used in these batteries pose a risk of thermal runaway, a dangerous chain reaction that can lead to fires or explosions. Aluminum-ion batteries eliminate this risk by replacing liquid electrolytes with solid-state materials that are far more stable and resistant to heat. This advancement makes aluminum-ion batteries not only more efficient, but also much safer for both vehicles and stationary applications. Cost is another area where aluminum-ion technology could outshine lithium-ion. By relying on more abundant and less expensive materials, aluminum-ion batteries have the potential to bring down the cost of energy storage significantly. This could make electric vehicles more affordable for consumers and increase the accessibility of renewable energy systems worldwide. The implications for the electric vehicle industry. Tesla's aluminum-ion battery doesn't just promise incremental improvements, it threatens to disrupt the entire electric vehicle industry. For years, automakers have struggled to balance the competing demands of range, charging speed, and affordability. Aluminum-ion technology could be the key to solving this equation, giving Tesla a significant edge over its competitors. One of the most immediate impacts will be on vehicle range. With its higher energy density, Tesla's aluminum-ion battery could enable electric vehicles to achieve ranges of over 500 miles on a single charge. This would put Tesla miles ahead of its rivals, many of whom are still struggling to break the 400-mile barrier. Charging speed is another game changer. One of the biggest drawbacks of electric vehicles has been the time it takes to recharge compared to refueling a gasoline-powered car. With the ability to charge in 15 minutes, Tesla's aluminum-ion battery eliminates this disadvantage, making electric vehicles more convenient and practical for a wider audience. The cost savings associated with aluminum-ion batteries could also have a profound effect on the industry. By reducing the reliance on expensive materials like cobalt and improving manufacturing efficiency, Tesla can lower the overall cost of its vehicles. This would make electric vehicles more competitive with internal combustion engine vehicles, accelerating the transition to electric mobility. Tesla's competitors will face an uphill battle trying to catch up. Companies like Ford, General Motors, and Volkswagen have invested heavily in lithium-ion technology and may struggle to pivot to aluminum-ion batteries. This could give Tesla a significant lead in the race to dominate the electric vehicle market. Beyond electric vehicles, aluminum-ion's broader applications. While the electric vehicle industry is the most obvious beneficiary of Tesla's aluminum-ion battery, the implications of this technology go far beyond transportation. From renewable energy storage to consumer electronics, aluminum-ion batteries could revolutionize how we think about energy storage across multiple sectors. In the renewable energy sector, one of the biggest challenges is storing energy generated by solar panels and wind turbines. These sources of energy are intermittent, producing power only when the sun is shining or the wind is blowing. To make renewable energy a reliable alternative to fossil fuels, we need efficient, scalable storage solutions. Tesla's aluminum-ion batteries, with their high energy density and long lifespan, could be the answer. Tesla's Powerwall and Megapack systems are already being used to store renewable energy for homes and businesses. With aluminum-ion technology, these systems could store significantly more energy in the same amount of space, making them even more effective. This could help homeowners achieve greater energy independence and enable utilities to build large-scale storage solutions that stabilize the grid and reduce reliance on fossil fuels. Consumer electronics is another area where aluminum-ion batteries could make a big impact. Imagine smartphones that only need to be charged once a week, or laptops that can run for days without being plugged in. The higher energy density and faster charging capabilities of aluminum-ion batteries would make these scenarios a reality, transforming how we use and interact with our devices. Even industries like aviation and aerospace could benefit from this technology. One of the biggest barriers to electric flight is the weight of the batteries required to power an aircraft. Aluminum-ion batteries, with their lighter weight and higher energy density, could make electric planes feasible, paving the way for a new era of cleaner, quieter air travel. Challenges in scaling aluminum-ion technology. While the potential of aluminum-ion batteries is immense, bringing this technology to market won't be without its challenges. Tesla will need to overcome significant technical, economic, and logistical hurdles to realize the full potential of this innovation. One of the biggest challenges is manufacturing. Aluminum-ion batteries require new production processes and materials that are more complex than those used for lithium-ion batteries. For example, creating silicon nanowire anodes involves intricate techniques to prevent the silicon from cracking during charging cycles. Similarly, solid-state electrolytes need to be produced with a high degree of purity to ensure consistent performance. These requirements may necessitate significant investments in new equipment and facilities. Sourcing materials is another obstacle. While aluminum is abundant and relatively inexpensive, other components like high-quality silicon and lithium are in high demand. Tesla has committed to sourcing these materials responsibly, but doing so at scale will be a challenge, especially as global demand for batteries continues to rise. Cost is another consideration. While aluminum-ion batteries have the potential to reduce long-term costs, the initial investment in research, development, and production is substantial. Tesla will need to find ways to achieve economies of scale and streamline its manufacturing processes to make these batteries affordable for mass-market applications. Regulatory approval is yet another hurdle. New battery technologies must undergo rigorous testing to meet safety and performance standards. Solid-state electrolytes, while safer than liquid electrolytes, still need to prove their reliability under a wide range of conditions. This testing process can be time-consuming and may delay the rollout of aluminum-ion batteries in certain markets. Finally, consumer acceptance will play a critical role in the success of this technology. While Tesla has built a reputation for innovation, many consumers may be hesitant to adopt a new battery technology without a proven track record. Tesla will need to address these concerns through education, warranties, and transparent communication about the benefits and reliability of aluminum-ion batteries. Tesla's vision for the future. Despite these challenges, Tesla's aluminum-ion battery represents a bold step forward in the company's mission to accelerate the world's transition to sustainable energy. By solving many of the problems that have held back lithium-ion technology, this innovation has the potential to transform not just transportation, but also how we power our homes, devices, and industries. Elon Musk's vision extends far beyond electric vehicles. With the aluminum-ion battery, Tesla is pushing the boundaries of what's possible in energy storage, creating solutions that are safer, more efficient, and more sustainable. Whether it's enabling longer-range electric vehicles, stabilizing the grid with renewable energy storage, or making electric flight a reality, Tesla is once again proving that innovation can drive meaningful change. This isn't just a breakthrough for Tesla, it's a breakthrough for the world. As aluminum-ion technology becomes more widely adopted, it will create a ripple effect that touches every corner of our lives. From cleaner air to more efficient energy use, the benefits of this innovation will be felt for generations to come. The race for the future of batteries is on, and with its aluminum-ion technology, Tesla isn't just participating, it's leading the charge. Manufacturing complexities. The transition from lithium-ion to aluminum-ion batteries presents a significant manufacturing challenge. Unlike conventional lithium-ion batteries, which are produced using well-established techniques, aluminum-ion batteries require entirely new processes. These innovations include the use of silicon nanowires for the anode and solid-state electrolytes, both of which demand precise handling and advanced equipment. Silicon nanowires, while offering the potential for much greater energy density, are incredibly delicate. During charging cycles, silicon naturally expands and contracts, which can cause cracking and lead to battery degradation. Tesla's engineers have developed proprietary stabilization techniques to counteract this issue, but implementing these methods on a mass production scale will require significant investment. The use of solid-state electrolytes also comes with its own set of challenges. These materials must be produced with an extraordinary degree of purity to ensure performance and safety. Even small imperfections in the electrolyte can lead to reduced efficiency or reliability. Scaling this production to meet Tesla's ambitious goals means rethinking existing battery manufacturing systems from the ground up. Tesla's history of solving seemingly insurmountable problems gives confidence that it will rise to the occasion. However, this will likely require not only new facilities, but also partnerships with advanced material suppliers and researchers to streamline the production process. The economic equation and developing and scaling aluminum-ion batteries comes at a significant cost. Research and development for such a groundbreaking technology is no small expense, and Tesla has already poured billions into its battery innovation program. From laboratory experiments to pilot production, every step of the process demands resources, both in terms of capital and human expertise. However, the potential payoff is equally enormous. Aluminum-ion batteries, once fully scaled, could significantly lower the cost of producing electric vehicles. Unlike cobalt, which is both scarce and ethically controversial, aluminum is abundant and relatively inexpensive. Similarly, advancements in silicon processing promise to bring down costs over time. Tesla's ability to balance short-term costs with long-term gains will be critical. By leveraging its vertically integrated business model, Tesla can control every step of the supply chain, from material sourcing to vehicle assembly. This integration not only reduces costs, but also allows for faster implementation of new technologies. The economic benefits of aluminum-ion batteries extend far beyond Tesla. As the cost of batteries decreases, electric vehicles will become more affordable for the average consumer. This could accelerate the global transition to electric vehicles, creating a ripple effect across industries and economies. Addressing consumer trust. Innovations as transformative as aluminum-ion batteries often face skepticism. For consumers, the idea of adopting a completely new battery technology may raise questions about safety, durability, and long-term reliability. Tesla will need to address these concerns head-on to ensure widespread acceptance of its latest innovation. One of the primary concerns is safety. While aluminum-ion batteries are inherently safer than lithium-ion batteries due to their use of solid-state electrolytes, consumers may still need reassurance. Tesla's rigorous testing protocols and history of prioritizing safety will play a critical role in building trust. By publicly demonstrating the resilience and stability of aluminum-ion batteries, Tesla can alleviate concerns and showcase their advantages. Durability is another key factor. Tesla's new batteries must prove that they can withstand thousands of charging cycles without significant degradation. To address this, Tesla will likely offer extended warranties and real-world data to demonstrate the longevity of aluminum-ion batteries. This transparency will help convince hesitant consumers that the technology is reliable and worth the investment. Tesla's reputation for innovation will also work in its favor. As a brand synonymous with pushing the boundaries of technology, Tesla has built a loyal customer base that is eager to embrace the future. Clear communication about the benefits of aluminum-ion batteries, combined with tangible performance improvements, will solidify consumer confidence. The industry responds. Tesla's aluminum-ion battery is not just a technological breakthrough, it is a direct challenge to the rest of the automotive and energy storage industries. Competitors like Ford, General Motors, and Volkswagen, which have heavily invested in lithium-ion technology, now face a choice: double down on their existing systems or scramble to catch up with Tesla's latest innovation. For many automakers, this is a daunting prospect. The infrastructure and supply chains for lithium-ion batteries are already well established, and pivoting to aluminum-ion technology would require substantial retooling. However, failing to adapt could leave these companies at a significant disadvantage. Tesla's ability to offer faster charging, longer range, and lower costs will set a new standard that consumers will expect from all electric vehicles. This pressure is not limited to the automotive sector. Battery manufacturers and suppliers will also need to innovate to stay relevant. Companies that specialize in lithium-ion production may need to explore partnerships with Tesla or invest in their own aluminum-ion research to remain competitive. At the same time, governments and policymakers will likely take notice of Tesla's advancements. With global efforts to combat climate change accelerating, the ability to store renewable energy efficiently is more critical than ever. Tesla's aluminum-ion batteries could drive new subsidies and incentives for adopting advanced energy storage solutions, further shaping the future of the industry. Tesla's competitors will need to act quickly and strategically to respond to this game-changing innovation. Whether through collaboration, competition, or entirely new approaches, the race to match Tesla's aluminum-ion technology is already underway. Beyond electric vehicles. The aluminum-ion battery is poised to revolutionize not only electric vehicles, but also renewable energy storage, consumer electronics, and even aviation. One of its most promising applications is in storing excess energy generated by solar panels and wind turbines, ensuring a steady energy supply even during low production periods. Tesla's existing products, like the Powerwall and Megapack, could be enhanced by aluminum-ion batteries, offering greater storage capacity in smaller, more efficient units and reducing reliance on traditional power grids. In consumer electronics, aluminum-ion batteries could dramatically extend battery life, allowing smartphones to last a week on a single charge, or laptops to need charging only once every few days. Additionally, the aviation industry could benefit from lighter, more efficient batteries, enabling longer electric flights and opening up possibilities for regional air travel and urban air mobility. Aluminum-ion batteries also represent a significant step towards sustainability. Unlike lithium-ion batteries that rely heavily on cobalt, linked to environmental and ethical issues. Aluminum-ion uses more abundant, environmentally friendly materials like aluminum and silicon. This shift reduces both costs and environmental harm, as aluminum is easier to source sustainably. Additionally, these batteries are designed to be recyclable, extending the life of raw materials and reducing waste. The improved energy efficiency of aluminum-ion batteries will further lower the carbon footprint of electric vehicles and other products. As renewable energy becomes more prevalent, these batteries will help maximize the benefits of clean power by efficiently storing and using energy. Transforming global energy systems. Aluminum-ion technology has the potential to transform global energy systems. Large-scale storage projects, such as grid stabilization, would greatly benefit from their high energy density and long lifespan, enabling more efficient energy storage during peak production times. This will play a crucial role in supporting a clean energy future, making renewable energy more reliable and reducing dependence on fossil fuels. Tesla's development of aluminum-ion batteries sets a new standard in energy storage, pushing the industry toward cleaner, more efficient solutions. This technology is a significant leap toward a sustainable future, with far-reaching implications for industries, economies, and society. As it becomes more widely adopted, aluminum-ion technology will drive progress in electric transportation, renewable energy, and beyond. But do you have another take on this? Let's talk.